In this part, I will continue to talk about householder transformation, and in order to see how this method works, I would like to solve an example. Apply householder transformations to the symmetric 4x4 matrix A, which has the following form, to produce a symmetric tridiagonal matrix that is similar to the original matrix A. First, on the right side in the green box, I provided you some tips how to define matrix of zeros and identity matrix in MATLAB, Octave or Scilab. Let's solve this problem now. We will follow the standard algorithm, and if you remember from previous slide, here on the right side in the blue boxes, I just give you the general formulas what we derived on previous slide. And we start our solution from defining parameter alpha. Just to remind you, the general formula in the blue box says that first we should look at the sign of the element a k plus 1 k at the kth iteration. Right now we have k equals to 1. This is how we start. And the sign in front of element 2, 1, it's 1 and sign is positive. If we look at this, we just take positive sign. Our j will be from 2 to 4, since our matrix 4x4 matrix n equals to 4. And here in the brackets, this is not a power, just remind you, this is an iteration and this is our first step, k equals to 1, and we consider elements from our original matrix A. So what we are going to do, we consider first column of the matrix A and we sum up squared elements from the first column. If we compute that, it will be minus 3. So we found parameter alpha. Now the general formula in the blue box on the right side shows us how to find the next parameter, parameter A. Now we know alpha, we plug alpha, which is known. Here again we look at the element of our original matrix A, and this element equals to 1. So we plug 1 here, and if we compute this parameter, it will be square root of 6. And once we found both parameters alpha and A, we can find all components of our vector W. As usual, W1 we assign as 0, W2 can be computed using this formula, and W3 we compute using this formula. So finally we are able to obtain all elements of vector W, and this is our vector. As the next step, we should compute householder matrix. Here in the blue box on the right side, on the top, I showed you just a general formula how to compute householder matrix. And we still have k equals to 1 and P1, this is exactly householder matrix. And we computed I is identity matrix, WK and WK transposed here. This coefficient we just took out from every vector from here and from here. That's why it's squared. Just for convenience, in order to make our calculations slightly easier. And below you can see the resulting matrix. This is our P1 householder matrix as a result of the first step. And finally, what we should do here, we should find matrix A2. And on the right side, in another blue box, I show you the general formula how to compute that. We use the product of the householder matrix, what we just computed, our original matrix A, and we multiplied again on P1 on householder matrix. And this is our resulting matrix A2 after the first step. First step finished. Let's say step 1 ends here. What we were able to get, we got zeros here and here. By symmetry, we have zeros in the first row as well. And let's continue and see what we can get after the second step. So let's continue. Step number 2. K equals to 2. And now we should repeat all procedure, but at this step we should forget about existing of our original matrix A, and we will work with matrix A2 in the blue box on the right side on the top. And these elements A2, this is elements from matrix A2. We consider this column. Now K equals to 2, which means that our J from 3 to 4 and still equals to 4. And what we are going to do, we look at the element here in order to figure out what sign should be. Element 3, 2 here from matrix 2, and this element is here. It's 1 and sign is positive, so we have -1 here. And if you compute it, it's going to be -5/3. Once we found parameter alpha, we can compute parameter R. Again, I provide you general formula in the next blue box. Now we plug alpha, what we just computed, -5/3. When we again look at the elements of matrix A2, and this element 3, 2 from matrix 2, which is 1, and it's here. So you can check calculations and you will get this number. Once we found parameter alpha and R, we can again compute all components for our vector W, W1, W2. In this case, it's going to be 0. W3 will be from this formula and W4 will be from this formula. And again, we compute householders matrix. P2 and compute matrix A3, and we can see here that we have exactly what we need. We were able to compute 3 diagonal matrices. Here we can see main diagonal and 2 more diagonals, and the rest entries are zeros. And we achieved our goal into 2 steps only. And as I mentioned before, we need n-2 householder transformations in order to achieve our result. Our n equals to 4, and we need just 2 steps in order to transform our original matrix A into 3-diagonal form. Now we can use this matrix in order to find eigenvalues for our original matrix and apply QR method. And we are going to talk about this method during next lecture.